Alright, so squares and rhombi, 6-4. Rhombi is plural for rhombus. So we're going to look at the definition of a rhombus first. A rhombus is a quadrilateral, so it has 4 sides. With 4 congruent sides. So because it has 4 congruent sides, it's similar to a square. Since opposite sides of a rhombus are congruent, a rhombus is a parallelogram because it meets one of the characteristics of a parallelogram. But this is the main definition right here of a rhombus. Just a quadrilateral with 4 congruent sides. Because all 4 sides are congruent, it also falls under the family category of a parallelogram. So it also holds all the characteristics of a parallelogram. It is in the same tier level as a rectangle. Because the difference, what's the difference between a rectangle and a parallelogram? What makes a rectangle unique? It's got 4 what? 4 right angles. So now what's making the rhombus unique from any parallelogram? It's got 4 congruent sides. Those are the unique features that differentiate a rectangle from a plane parallelogram and a rhombus from a plane parallelogram. Then an interesting thing is going to happen when the rectangle and the rhombus come together and have their love child. What kind of figure has 4 right angles and 4 congruent sides?
Square.
Square is the love child of the rhombus and the rectangle. It's true. Very true. All right, so let's look at some theorems associated with this. So theorem 6-11. The diagonals of a rhombus are perpendicular. This occurs because the minute you have all 4 sides congruent, the diagonals become not only congruent, not only do they bisect each other, but they are also perpendicular. Which creates an interesting theory. We'll look at that more in a minute. Theorem 6-12. Again, you're not to memorize theorems, but what they say. If the diagonals of a parallelogram are perpendicular, then what do you conclude? What can you conclude? That it's a rhombus. Then the parallelogram is a rhombus. So all theorem 611 and 612 are to each other. Well, they're not exactly converses. But theorem 612 uses theorem 611 to say, okay, now if I find a quadrilateral that has perpendicular diagonals, I can now assume it's a rhombus. And then 613. Each diagonal of a rhombus bisects a pair of opposite angles. Now we know that because a rhombus is a parallelogram, that opposite angles are congruent. But another thing that's special about the rhombus is that those diagonals bisect those opposite angles. So that doesn't happen in a rectangle, that doesn't happen in a parallelogram, it only happens in a rhombus. And I misspoke a little bit earlier, the diagonals are not congruent in a rhombus unless it's a, what do you think? A square. Because what figure was the diagonals congruent in? The rectangle. So let's look at an example before we go on to the squares. So example 1 says that use rhombus. So the minute they tell me it's a rhombus, it has all the characteristics of the parallelogram plus the new characteristics of the rhombus, the fact that the diagonals are perpendicular and that the diagonals bisect the opposite angles and that all four sides are congruent. So use rhombus DLMP with DM equaling 26. What does this notation mean? The distance from D to M is 26. To determine whether each statement, oh, I'm losing pen. Is true or false. And justify your answers. Bless you. All right, so here's D. Here's L. Here's M. And here's P. And then also connect D to M and L to P, and this right here is O. So the information that they've given us is that this is a rhombus. So that holds a wealth of knowledge for you. And then the other thing that they've given us is that from D to M is 26. So if from D to M is 26, what's from D to O? What? 13. And from O to M? 13 also, right? So I would go ahead and write that in there. So the first question is, because that's what I can conclude from the fact that dm is 26. So the first question that I'm asking you is, the distance from O to M, 13. True or false? True, because we just concluded that, right? So true, but why? What's your justification? Does that come from specifically because it's a rhombus, or specifically because it's a rhombus as a parallelogram? Does it come from the parallelogram or the rhombus part of it? It comes from the parallelogram, doesn't it? So since a rhombus is a parallelogram, I'll use shorthand notation, its diagonals bisect each other. Therefore, if dm is equal to 26, OM is equal to half of dm, which is equal to 13. All right, second question. Is segment MD congruent to segment PL? With just the information that you've been given, is DM congruent to PL? And those are what parts of the rhombus? Diagonals. Are diagonals congruent in a rhombus? Are they congruent in a parallelogram? No. So is this true or false? You will learn in a minute that it is only true when that rhombus is a square or a rectangle, right? So it's false because the diagonals are not congruent in a parallelogram or a rhombus. Okay, last question on this one. C, the measure of angle DLO is equal to the measure of angle LDO. So they want to say DLO, so follow with your fingers, DLO, that's this angle here. They want to know, is it congruent to LDO, from L to D to O, this right here. In the rectangle, didn't you have 4 isosceles triangles in the rectangle? Is this a rectangle? No. What do you know about the diagonals of a rhombus? What new things have you learned? They're perpendicular. So immediately I need to put a right angle here. That makes this what kind of triangle inside the rhombus? A right angle. What do you know, if this is 90 degrees, what do you know about these two? They add up to 90 degrees also, right? Do you know that this is exactly equal to this one? No. The diagonals are not necessarily congruent. They bisect each other. because it's a part of the parallelogram family, but they are not necessarily congruent. Only if that rhombus becomes a square do they become congruent. So these are not, I have no knowledge that these are congruent. The only thing I can say is that these add up to 90. What kind of angles add up to 90 degrees? Complementary angles. So my answer to here would be false. These angles are complementary and you might want to put in here just for your note purposes that diagonals are perpendicular. Creating right triangles. All right, so as of today, things are going to start to get a lot more complicated as far as what goes with what and how do I separate the two. So take out your pink sheet. Let's go to the rhombus and add the new things. One more, come on. Oh, it's a little fuzzy. What are the 3 new things that we've learned? What's the very first thing you learned? Okay. Well, before that, what was the definition? Yeah, you have 4 congruent sides, right? So, number 1, you have 4 congruent sides. That's technically your definition, but it's still a characteristic of that. And then number 2, what next did you learn? Diagonals are perpendicular. And what was the third thing? What else do the diagonals do? There you go. So diagonals bisect opposite angles. So if I back this up, this rhombus includes these 3 things, plus those 6 things, plus that, right? So a diagonal really has 9, really 10 characteristics to it. Or what did I say? A diagonal? A rhombus. A rhombus has 10 characteristics to it. The rectangle has, oh, I put 7 and 8 here. I guess I should have put 7, 8, and 9 here. A rectangle actually has 9 characteristics if you include the definition of a quadrilateral. So then we're going to come to a square. So this square, as I said, the square becomes the love child. Of the rectangle, oops, can't see it all, of the rectangle and the rhombus. Because the square is going to have all of these and all of these in one figure. We're going to take that rectangle, the rhombus, and merge them and combine them, which means the square has 4 right angles. Its diagonals are congruent. It has 4 congruent sides. The diagonals are perpendicular, and the diagonals bisect the opposite angles. So the square is going to have all 5 of these here, plus these, plus this up here. So we're going to go ahead and add these right now that we're looking at it. So our square technically has, so I'm going to call this 7. I should probably use a different color. So square has 4 right angles, so we'll make this 7, 8, and 9. Has diagonals that are congruent. 9, it has 4 congruent sides. 10, it has diagonals that are perpendicular. And then 11, it has diagonals bisect opposite angles. So in a square with the diagonals drawn in, what kind of triangles will be in the square? Right? What kind of right triangles? Scalene, isosceles. There's no equilateral right triangle. If the diagonals are congruent and they bisect each other, won't you have scalene right triangles? I'm not scalene, isosceles right triangles. So this one had isosceles right triangles in, or isosceles triangles in it, right? Not right. This one has right triangles, so if you merge the two, we now have isosceles right triangles. So is there a lot of stuff that you have to sift through and keep track of? Yes.
For the triangles and rhombus.
Say that again.
Triangles and rhombus.
They could be they are scaling until it becomes a square. When it becomes a square, then they become isosceles right. Does that make sense? Okay. So I'll show you here in a minute when I'm done what kind of game that you can create with all this information to try to help you memorize and learn all of these characteristics and what belongs to what. All right, so put that away. Let's talk about the square. So based upon what we've done, we already know a lot about the square. So your square is a quadrilateral that is both a rhombus and a rectangle. In other words, it has 4 right angles and 4 congruent sides. And so your square would look like here's its 4 right angles, bless you, and 4 congruent sides. I want to look up a more difficult question than what I have in my notes regarding your square. So give me just a minute. All right, so example 2. I want you to determine whether parallelogram Wxyz is a rhombus a rectangle or a square. Technically, a square is both a rhombus and a rectangle. But if you call a square a rhombus or a rectangle, I'll consider it wrong, because we need to go with the most specific naming of that object. So you cannot name a square a rectangle because it's more specifically a square. And so you're looking for, if you're going to determine if something's a rhombus, what makes a rhombus different from the rectangle and different from a parallelogram? What makes a rhombus uniquely different than a rectangle or a parallelogram? What would I be looking for in here? 4 congruent sides, right? Was there something else that made it uniquely different than a rectangle or a parallelogram? What was the other thing that made it uniquely different? The diagonals are perpendicular. Which one's easier to figure out in a coordinate grid system? What do you have to use to find congruent sides? Distance formula. What would you have to use to find perpendicular diagonals? Slope. Which is easier to figure out? Slope. I would be going for this one before I'd go for that one. All right, a rectangle. What makes a rectangle uniquely different than a rhombus or a parallelogram? 4 right angles. What else? What about the diagonals? Didn't we realize, though, that congruent diagonals in our homework with rectangles doesn't always go with just rectangles, right? It went with an isosceles trapezoid, which you'll learn about later. So I'm less likely to look at the diagonals in a rectangle, only because, I mean, visually we'll be able to tell if it's a trapezoid versus a rectangle, though, right? So you could still do that. So we've got congruent diagonals. But what requires you to figure out if the diagonals are congruent? Distance formula. What requires you to figure out if you have 4 right angles? How do you figure out 4 right angles give you perpendicular lines? We use slope for perpendicular lines. So again, I'm going to look for 4 right angles. So while I'm testing this for a rhombus or a rectangle, I'm going to be testing the slope of the diagonals and the slope of the sides. So I'm going to find actually 6 slopes, because I want to test it for a square. Testing it for a square, 4 right angles isn't enough, is it? I need to also test its diagonals, because otherwise, if I want to test the square, I either have to look at the fact that it has 4 right angles, but then I also have to see, are the sides equal? Well, if I try to find, are the sides congruent, what am I going to look for? How do you find congruent sides? Distance formula again. Do you like the distance formula? No. So we could find, 4 congruent sides, but I'd rather test this and this. It's quicker than doing the distance formula 4 times. So I'm going to give you the ordered pairs, and the ordered pairs are W is 110, and X is -40, Y is 72, and Z is 1212. So I need to have a 12 by 12 grid in order to graph this, right? But looking at this, aren't all of my points, with the exception of one, pretty much in the first quadrant? Right? So I'm going to do this instead. I'm going to make that. That ought to get all my points on there. So plot your points. if I'm going to take a shortcut and not use the distance formula, I do have to find all 6 slopes, meaning I still have to find the slopes of these diagonals here. Because if all I do is look at the diagonals and find the slopes of the diagonals and say that they're perpendicular, I haven't proven that it's not a square. So I'm going to find all 4 slopes. A couple ways I need to see it. Either you need to list out here to the side the slope of Wz is equal to, and specifically you're telling me this what this slope belongs to, or you're naming the slope right here and you're saying slope is equal to. So you're naming it right there on the line so I can see, oh, that slope belongs to that line, that slope belongs to that line, and so forth. You're being really clear with me. Otherwise, if I can't tell what slope belongs to what, and you haven't named them and distinguished them, then I won't give you full credit. So go ahead and find all 6 of your slopes by stair-stepping, rise over run. You could use algebra if you want to by what? But why? Stair-stepping is quicker. So the first thing I did was find the slopes of the opposite sides, because if the opposite sides are not equal, it's not a parallelogram. And if it's not a parallelogram, is it going to be a rhombus, a rectangle, or a square? No. So don't let your eyes do the assuming, do the math. So now that I have opposite sides are congruent slope-wise, that means that opposite sides are parallel. I'm going to go ahead and find the slopes of the diagonals. What do you notice about the slopes of the diagonals? These are opposite and reciprocals. So what does that tell you? That they're perpendicular, right? And so I know right there that I have a perpendicular diagonals. So I have a parallelogram, and then look at the consecutive sides here. This one is 2/11, and this is 2. Are they opposite signs? Opposite signs? No, nor are they reciprocals. So is this a right angle here? Is that perpendicular? So if one of them isn't, it doesn't matter what else is. None of them are going to be if it's a parallelogram. So what is it? Is it a rhombus, a rectangle, or a square? I have opposite sides are parallel, so it is definitely a parallelogram. Now we knew that going into it. But all I have are the diagonals are perpendicular. I don't have 4 right angles. So what is it? It has to only be a rhombus. So here's your answer. Parallelogram. Wxyz is a rhombus because the diagonals are perpendicular and consecutive sides are not perpendicular, and I'm going to put in parentheses, meaning it's not a square. Now, we just put that in for our note purposes. All I really have to have from you is that parallelogram. The parallelogram is a rhombus because the diagonals are perpendicular. And your work supports that. My work is clearly labeled here and here. So when I go to look at your work, I can tell what belongs to what. Okay? So this is something that we've been working on with every single section, right? So now we just tap that into it. All right, so now I'm going to show you your game that you can make.